Hello! Yes, and welcome to our quiz F.4 video where we can chat this together. This video aligns with numbers 23 through 38 from the review that's posted on the Teams page for the final. Please go ahead and check that you're doing this video after you've completed the quiz. This is meant to be a check to see how you did on the quiz. I would recommend completing the quiz first and then watching this video. So if you haven't done that, go ahead and pause the video, get yourself caught up. But if you're ready to go, then let's just dive right into it. So looking at number 1 here, they ask us to sketch a graph of f of x equals this logarithm. Be sure to show several points along with any asymptotes. Identify the domain and range. Excellent. So the first thing we can remember is that domain and range, we can do that automatically. Remember that the range for a logarithm is always negative infinity to infinity. The domain we get from the argument, we'd say x minus 2 has to be greater than 0, which means x has to be greater than 2. So that would become 2 to infinity there. That's also the equation of my asymptote. 2, x would equal 2. And there we go. And now from here, let's go ahead and graph this function on our graphing calculator. So let's go to y equals, let me get rid of that. So typing this in, if you have math alpha math, you can totally just do this normal. So log 3 parentheses x minus 2 and then plus 3. If you do not have math alpha math, you're going to need to take a different approach here. So do parentheses. We'll have to do change of base. So it'll be log of x minus 2, close that parentheses, divided by log of the base, so log of 3, close that parentheses, close the parentheses for the entire logarithm, and then plus 3. Now if I graph these things, they should fall right on top of each other. So it should look like just one line. Perfect. That tells you I did it right, which is good to know. So next what I want to do is I want to look at a table of points here. Right? It says in our instructions, be sure to show several points. So I'm going to do second table. And I'm down in the negatives. Of course, there's nothing there. And here we go. So let's see, can we get to 5 before the end? No, we can't. It happens at 11. That is okay. So I can do, let's make a table. X, Y. I'm just going to go 3. Let's do odd numbers here. 3, 5, 7, and 9. So 3 is 3, 5 is 4, 7 is 4.47. 9 is 4.77. And then I can plot these points here. So 3, 3, 5, 4, 7, 4.47, 9, 4.77. Beautiful. Now the key thing with this one is to remember that even if the graph doesn't show it going all the way down, we know that that asymptote here it runs along next to it. So we need to be sure to show that this graph continues all the way down, like so. Beautiful. And that's it. That's all we need to do for this one. Well done, team. All right, let's solve a couple logarithmic and exponential equations here. So for problems 2 and 3, find the exact value and a decimal rounded to 2 decimal places. Okay, so remember, the exact value means I should never use my calculator. So let's do that one first. So looking at here, I'm adding logarithms. I need to remember my properties. So this will become x plus 4 times x minus 2, and 1 in the argument of one logarithm equals 2. And then from there I can rewrite this. So this is 4 to the second equals, let's multiply this out, x squared plus 2x minus 8. So 4 squared is 16, x squared plus 2x minus 8. Let's subtract the 16, so I'll have 0 equals x squared plus 2x minus 24, which I can then factor as x plus 6, x minus 4, which tells me that x equals negative 6 or x equals positive 4. All right, so let's check our work. If I plug in -6, remember we have to check for extraneous solutions here. -6 plus 4, that'll give me a negative number here. So that means right away I know that this is extraneous. I cannot plug that in and get a true statement because I would get negative numbers in my arguments. Remember, our arguments have to be positive. However, when I plug in 4, I'd get a positive number here, a positive number there. So x equals 4 is my solution here. All right. Now, what about if it's an exponential equation? Well, a question we should answer, what about, oh goodness, where'd that go? The question we should answer, what about the decimal rounded to 2 decimal places? Well, I think in this case, we don't need to do that since this is an integer. That might not be the case with number 3 here. So let's look here. To solve this one, it's an exponential equation, so I'm going to need to convert it to a logarithm. To do that, I need to get the exponent all by itself, so 40 over 3. So I will get 5 to the 2x plus 1 equals 40 thirds, and then I can convert this to a logarithm. So this would be log base 5 of 40 over 3 equals my exponent of 2x plus 1. I can subtract 1 and divide by 2, and then divide that all by 2, and that is what x would equal. This is one that I think they want to see a decimal for as well. So this is the exact value, right? No calculator required. Now let's go ahead and find the rounded value. So again, I'm just going to math this. If you need to do change of base, that's fine. So log base 5 of 40 over 3, and then minus 1, and then, oh goodness, if I wanted to do this right, I'd put parentheses all around all this, but we're going to just divide this by 2. This is 0.304, which would round to x equals 0.30. Well, I guess we should say it's approximately 0.30. There we go. So our exact value is this one here. Our rounded value, this one here, 0.30. Excellent. All right, last one for this one. It's really a short unit. It's just logarithms and exponents when you think about it. 3,500 was invested in an account that earned 6.7 interest compounded monthly. How much was in the account after 25 years? Okay, so recall all the formulas we need to know. We need to know compound interest, continuous interest, half-life, population growth. We need to be able to do all of that for this unit. So with that being said, let's review compound interest. That's A equals P times 1 plus R over N to the NT. Again, you're allowed to use your notes on the final, so please be sure to look at these notes. Make sure you're using, or looking at your notes. Make sure you're using the correct formula when you do these problems on the final. So P is the initial amount, so I would say A equals 3,500 times 1 plus R, 6.7 as a decimal, so that would be 0.067 over N is the number of times compounded. Monthly is 12. To the 12 times, how many years? 25 years. 12 times 25. And this we can just put in our calculator. So we'll have 3,500 times 1 plus 0.067 divided by 12, close that parentheses, to the up caret, parentheses, 12 times 25, close parentheses. And what do we get? A massive number, because that interest rate is super high, $18,598. So $18,598, and we'll round down here 93 cents. And there we go. That's it for our quiz for Unit 4. Hopefully we're feeling good about it. If you're feeling good, go ahead and get ready for quiz F.5. Check the remainder of the review, and then try the quiz on your own. This is Mr. Carter signing off. I'll see you next time.